Hi, I'm Bart, and welcome to the Digital Transformation Club. Today, I'm really excited as we have Pieter Abbeel, a leading name in AI globally, and we have Philippe Baecke, professor in data analytics and AI of Vlerick Business School. Philippe, the floor is yours.
Okay, today we have Pieter Abbeel over here. Pieter Abbeel is a professor and director of the robotics lab at UC Berkeley. He's also co-director of the Berkeley AI Research Lab and co-founder of Covariant, a company that is specialized in AI and robotics. And besides that, he's also an advisor of OpenAI, an AI research company that was founded by Elon Musk. Further, he also has an incredible podcast called The Robot Brains, which I really love. So Pieter, thank you for being over here. You're really a thought leader, making the link between machine learning and robotics. You're very recognized in the field, having already received a lot of best paper awards. So Pieter, welcome to this club. My first question. What are you most proud of? Your moment as an actor in a Verizon commercial or your time as a point guard on the KU Leuven basketball team?
Wow. Well, Philip, thanks for having me. Really excited to be here. And that's a tough opening question there. If I will say, both were a lot of fun. And I think a lot of people can imagine what it's like to play on a sports team, and it's a lot of fun. I feel like team sports just bring something, to me at least, but I think to a lot of people, where it carries over into business, actually, I would say, to learn to work together and being something together. Now, the Verizon commercial to me was just a crazy experience because it's a one-time thing, and I had no idea what it would be like. And it was a great day, one day in Hollywood, and gave me a sense of what that life is like. And I can tell you, just to record one sentence can take a lot of takes before everything's right, it turns out.
Oh yeah, I agree. I'm also a team player. I play football, and it helps to work together with people. I agree with that. Now, maybe let's focus on you first, and just in general. We're wondering what drives you, what fascinates you, Pieter.
In general, I've always been curious about pretty much anything I see around me. I'm curious, okay, how does this work? Why does it work this way? And so when I had to choose what to study, it was actually very hard because everything is so interesting to me. But ultimately, what really drew me to what I'm doing now, which is artificial intelligence, is that when I thought about, what makes us maybe most stand out as humans compared to other creatures on this planet, it's the fact that we can think, come up with new ideas and so forth. And at first I was like, oh, it would be interesting to study neuroscience to try to understand how we do that. But I quickly realized that seemed very, very difficult to kind of measure things in the brain and correlate that to how it works. And that maybe a more viable path forward is to try to engineer an artificial intelligence, and in that way understand more of what intelligence is really all about.
Interesting, and that's a little bit what you're trying to do now with your company also, Covariant, where you bring AI together with robotics. Where do you think this technology will go? Where is it today, and where will it go in the future?
Today, if you look at robotics, there's the stuff that you see in the media, but then there's where the robots actually are. And where are the robots? There's 3 million robots in the world. If you want to go find them, you'll find out that they're mostly in manufacturing, car factories, for example, electronics factories. And when you look at what they're just doing the same motion over and over. And they're very diligent. They'll keep doing that motion for years and years and years without ever taking a pause. But it's very limiting if all a robot can do is repeated motion. And so what's so exciting to me, and why we started Covariant, and there's other companies, of course, doing related things because it's kind of the right time for this, is that the moment is now to start building robotic applications that are more intelligent, where the robot can actually see what's in front of it, react to it, and then based on that, make the right decision. And so for Covariant, that has meant putting robots into warehouses. So if you go online, you order something, well, what does that mean? For you, it means something shows up at your door a couple of days later, or maybe even the same day sometimes. Behind the scenes, there's a massive logistics supply chain at work. And part of that is that these objects that you order need to be retrieved from a shelf or a box in a warehouse into the box that comes to you. And that's a robotic manipulation problem that we're working on solving, and that is, one of the big things Covariant is bringing into the world right now.
At this moment, you're mostly focusing on manufacturing, right? Where you have like a lot of standardized processes. Do you think these robots also will enter our houses? In other words, what do you think? Like, how long will it take before a robot will put my clothes in the washing machine or do the ironing of my shirts?
Yeah, it's an interesting question. The way I see it is in some sense that there's a spectrum, but even though it's a continuous spectrum, I'd split it into 3 regions. One region is pure manufacturing, repeated motion like you see in car factories. Then the middle of the spectrum is where we are just about to bring it into the world today, that is semi-structured warehouses, where the objects the robot encounters are different every day, objects never seen before, it needs to handle in new configurations and so forth. But it's still inside a facility that you have control over. And so it's not completely open-ended. And then there's the fully open-ended, a robot in a home. And in my experience, and I think in everybody's experience, getting AI to work, it becomes harder and harder and harder the more variation you allow. And so I'd say right now for robotics, we're in that middle range where things are becoming possible, which is very new from even just a few years ago. I'm really exciting, but is not yet at the level where it could deal with the variation you'd have in, a robot going into 100 different homes or anything like that.
Maybe let's go back to your career. You lived in Belgium. You lived in Brasschaat, studied electrical engineering in KU Leuven, then moved to the US, studied over there at Stanford, starting being a professor at Berkeley, even having your own company now. It's really an amazing journey, It's very inspiring for a lot of people of us. But if you reflect on that journey, what are like key important steps in that journey that brought you where you are at this moment?
Yeah, there are a few. So I would say one of the first big things was towards the end of my studies at Leuven. I was studying electrical engineering, as you said, Philip, and I was trying to figure out what to do next. And AI, artificial intelligence, just seemed the most interesting thing to do. And so I started looking, where is that being done and where is that done in the most kind of prominent way? And it became very clear that there were 4 schools in the US that were leading the way: Stanford, Berkeley, Carnegie Mellon, and MIT. And so that's where I really wanted to go. Now, one thing you'll notice, if you go to the US to study, going to university here is very expensive. It's not really subsidized by taxpayer money. It's subsidized by essentially your own bank account, and it's really expensive. But then some professors at Leuven told me, look, there is this organization, the Belgian American Educational Foundation, BAEF, and they give out fellowships for a first year of study in the US. And so I applied for that, and that was a big enabler to be able to afford to go for that first year. After the first year, I was hired as a research assistant and so forth. And so once you're hired, all the costs are covered. But I would say that was a big enabler, the BAF, the foundation, allowing that first year to go prove myself, to then be hired and continue into PhD. Another big thing was my first research advisor at Stanford, Daphne Koller. She still is one of the leading researchers in machine learning and really got me into research. She gave me the opportunity. She took a chance on me and said, okay, well, why don't you join my lab and let's see how it goes. And from there, then a new professor showed up actually at Stanford for my PhD, Andrew Ng. He was just starting out. He's right now, back then he was just starting out, but right now he's possibly the best known professor in machine learning because he has put many of his classes online and are very, very popular. And so Andrew took me into his lab as his first student, and that was just amazing to see him start out his lab from nothing because he just arrived to what it became and be part of that. And so there's this couple of moments there where working with the right people, I would say, every time and being exposed to the right people made the world of difference in kind of where I am today. And then another big event for me, at least, was, of course, Berkeley taking a chance on me to let me become professor. It's actually pretty common in the US, which is interesting. About 50% of the professor hires in computer science are straight out of PhD. So there's no, you finish a PhD, you become professor right away. Berkeley took that chance on me, and that was a big opportunity for me to start my own lab. And then from there, I mean, probably the best known big opportunity I got was when OpenAI was founded. OpenAI was actually co-founded by one of my students. So one of my doctoral students was graduating, and he said, okay, I'm going to co-found a new company, and it's going to have some pretty big names in it also, and amazing other researchers. And of course, the biggest name in it was, well, he's still the biggest name today, Elon Musk, who was funding that OpenAI at its beginnings. And so the exposure to Elon Musk was a pretty big deal for me too, because I mean, you see him in the media, you see what he does, but when you're actually interacting with him, it's interesting because he actually, when you see things in the media, it's easy to think, okay, media just wants a rock star, just wants somebody who's iconic and is just blowing it out of proportion. But when you interact with him, the guy is just phenomenal. Like, you talk with him, at the time he was just getting into AI. He hadn't really gotten into it, and part of founding the company for him was for him to get into it. But he just asked a lot of really good questions. He's really interested in exactly like, okay, why are we building, at the time, this OpenAI gym? Why are we building, these algorithms? Why is this promising and so forth? Is that really big enough? And that was a big part of it to me. Like, is what we're doing really big enough? Like, just something incremental is not going to cut it. It's got to be something really big and important. Otherwise, it's not worth our time. And I think that spirit is just, when you work with him, an organization that he's part of, it's just, yeah, it's there. It's got to be big, important, impactful, good for the world, all those things.
He's a very inspiring person indeed. And Andrew, indeed, if you look at online courses for machine learning, it's also a course I frequently recommend to my students. Now, as a professor at UC Berkeley, you see a lot of like companies, startups that are investing in AI, that are creating AI-driven innovations. Some successful, others really fail. In your opinion, and based on your experience, what are the key criteria that make the difference between a success and a fail over there?
First of all, I would say I wouldn't call myself an expert in calling that out, what's going to be a success or a failure. It's very hard. I mean, even the most renowned venture capitalists make many bets that don't work out because there's so much uncertainty in the early days of a company. When I see kind of what works, I think the first criterion is whoever are the founders of the company, they have to be really, really excited about what they're about to do. And I mean, like, you need to be so excited because it's going to be a lot of hard work, but also the journey is a lot longer than most people think. Like, you think, you see these things and you think they're overnight successes, and sure, sometimes they are. Like, there are a few companies out there that are overnight successes, right? Like Instagram, they only ran for a very short time before they were acquired by Facebook for $1 billion. But most companies I see out there, like, they are 4, 5, 6, 7 years into their journey before they start really registering as, wow, this company is successful. Look at a company like, for example, Stripe, which is one of the most successful private companies these days. I mean, they're always in the news now, and as of 2, 3, 4 years ago, they've been in the news a lot. But there was a whole journey before that, and they started long before it became clear that they were going to be the winner, right? And maybe to them it was always clear, but I mean, it's a long journey, so you need to be super excited and have a lot of endurance is maybe the way to put it, to see through it. I think the other thing is you need to be really focused, willing to kind of iterate over things. Pick something, push on it really hard, get fast feedback. So you want to build something, see how it fares. If people try to use it, if you try to use it yourself, anybody else tries to use it, and iterate on that and be very, very perceptive. It's very easy to think that, of course, you need to have your own vision and you need to put that on. You don't want to, design something by putting out a survey and try to accommodate everyone. That never works. But you do want to take that feedback and think through how that might change your vision a little bit and steer your vision based on what you see. I think the other thing is you need something. I think the big companies are always doing something either very new or something really, really old in a new way. So it's not like jumping on the latest trend, but it's like, okay, this is something that nobody's doing yet, and I'm going to do it. Or look at Stripe, for example, online payments and so forth. I mean, it was all a mess. And so they're like, okay, nobody's been working on this. Let's just do it. Look at Uber, taxis. It was like getting a taxi was always a pain. Been around for 100 years. Let's just change it up. And so I think big part of is, maybe this is part of the Elon Musk influence, but I think sometimes the bigger you think, the easier to succeed actually, and much harder to succeed with something smaller. And that might be counterintuitive, but the bigger you think, the easier to get other people excited, the easier to have that excitement yourself and to really want to push.
It seems to be a little bit the Elon Musk strategy you're pointing to over here, eh?
Yeah, but I think it's not just a strategy. I think there's a lot of truth to it. If you're going to recruit somebody, right? Just think about it. You're going out to recruit. If your company is even medium successful when you start out, within a year or two, you're busy recruiting, and you're competing with all these other companies trying to recruit people to join your company. And the way market forces work, probably the chances that they make a certain amount of money in your company or another company is probably somewhat similar if you're both competitive. So why are they going to join you? Because the problem you're solving is more exciting, more interesting. And so it needs to be something big and exciting that can have a big impact on the world. And then they will be like, oh, well, I can choose between two things I pay equally well, but this one is actually more interesting. I'm going to join this one.
Since we're talking about recruiting and people, if you look at an AI project, these are typically quite complex projects. What is typically the team you compose if you want to realize a project for an organization?
I love that question, Philip, because I think that's been changing so much over the last 5 to 10 years. So when I think about modern AI, the big moment is in 2012 when Jeff Hinton from Toronto and his students show that very large neural networks are able to learn from data to recognize what's in images. Not perfectly, but much better than anybody anticipated at that time to be possible. And then everybody started building on that. And you think about 2012, that breakthrough. At that time, there might have been one person in the world who could have done it. It was the student who programmed that breakthrough, who had 2 GPUs, and nobody else was working with GPUs for AI. Pretty much it was, GPUs was for graphics, but that's changed. I mean, NVIDIA has become one of the biggest, it's the biggest chip company now. I mean, it wasn't back then. And that student could figure it out. And so at the time, you needed to be a really good software engineer, AI expert to get anything working. But then over time, as more and more people figure it out, and there's open source releases and more tutorials and so forth, I would say the amount of kind of very detailed expertise that's needed to get something up and running is becoming less and less. Now, of course, you want to invent something that's never been done before, like a research thing, you still need a lot of the expertise. But if it's more something where you say, I want to build a product, I know maybe that, an AI vision system should be able to recognize things in an image. I want to set up a product that uses image recognition or uses speech recognition and so forth. These days, it's not only that there's open source, there's actually cloud products out there that you can use. And so I would say that these days, The key thing is to understand your problem. So you need to understand that if I want for my problem some kind of image recognition, some kind of speech recognition, maybe some kind of data analysis, I want to first go see, is there something in the cloud services realm that I can just rely upon? I'll still have to put an interface to it. It's not that I'm just done, but I'm not going to necessarily build my own neural networks. I might just rely on that. And then the big question becomes, and that's the hard thing, when you choose such a service, which one do you choose? And is it going to be good enough? And the only way to really find out is to feed your data into the service. And that's key. For many, many things in the world, when you buy a product, when I buy a cup for water, I don't need to test it with my water to see if this cup's going to work. I can see it in the store and I just know this cup, it looks good. I like it. It's going to contain water just fine. With an AI product, you don't know, because when you have an AI product, it's trained on data. And so if your data is very different from the data it was trained on, then that product might not do so well. And so that's really key, that understanding that the performance of the AI system that you get from the cloud typically these days is going to depend on the data it's trained on and how it relates to your data, and actually testing it.
I agree, and over there are even opportunities for organizations that are less mature in AI to still start leveraging this technology, right? You don't need to have all the techies anymore. It's like translating business with some tools that are available, and that makes it interesting, right?
I agree. Like one of my favorite examples of this is this tool. Not sure if you're familiar with it. It's called Descript, and it's a video editing tool. And so I use it sometimes for lectures. I will record a lecture. And what Descript does, it doesn't just record a video, also records sound, of course, and then it does speech recognition on the sound and gives you a transcript. And that transcript is by no means perfect. It's pretty good, but it's by no means perfect. But then what they let you do is they let you edit the text directly in the transcript and accordingly remove things from the video. And so instead of having to scroll through your video and be like, oh, here is where something I should remove, you can just look at the text, remove it, and it automatically knows the timestamps in the video. If you think about, do you need the world's best speech recognition for this? Not at all. You need something decent. And I think that's exactly what, Philip, what you're alluding to, that there's a lot of AI capabilities now. If you're clever and you see like, wait, this can actually unlock this new product, I think that's where a lot of opportunity is, to have the insight for a pain point that can be resolved or a new opportunity that can just be put out there. And AI doesn't need to be perfect. Of course, I want to be clear. Some things AI needs to be really good for, like self-driving cars. You don't want some 90% performing self-driving car. That's there. It's really a research effort to get that to the level it needs to be. But many opportunities for people who have great product feel and insights.
We talked already about startups, but you see also big traditional organizations, telcos, utility providers, the big banks adopting AI or even trying to build AI models themselves. What do you think over there are the main adoption barriers?
For big companies, for many of them, they have so much valuable data, right? And so much opportunity. If they could analyze that data to find patterns that could help them improve their business, find better efficiencies, find maybe new profiles of customers that they've been ignoring and that they could make much happier if they maybe customized some of their approaches and so forth. And the big question, I think there is two big things there. One is you need to know what questions to ask, like what even to look for. And then two, you need, of course, people who can use the tools to run over your data. And then there might be a third aspect, which if your data is not actually accessible, if you don't store it in a convenient way, there might be a whole, a lot of work there to make it accessible to the tools. But I think ultimately, assuming you store your data in an accessible way, it's somebody who asks the right questions, as well as the ability to use the tools that can analyze that data and showcase, unexpected patterns, immediately flag things that are, maybe not the way you've seen them. If something is so different this month from the last month, anywhere in your operation, if you can notice that immediately, that can make a big difference.
Do you think culture is also an aspect over there? I can imagine, for example, if you're if you're a data scientist in a big bank versus a data scientist at OpenAI, you're in a totally different environment.
Yeah, definitely different companies have very different cultures, and those are two examples of probably somewhat extremes. Though some of the big banks are actually quite active in AI, of course. I would say part of it is maybe that there is a big difference between having a AI idea and having a finding and turning that into actionable insight or a product. And I think when you're at the research place, getting the insights, the new ideas tends to be enough, and it's very exciting. It's a lot of fun to focus on that, but then turning it into something that's an actual product often requires a lot more work. Also, indeed, requires collaboration with many other parts of the organization, and hence I think is always going to be a bit slower.
Yeah, over there I agree. You see, like in a lot of organizations, a lot of proof of concepts, but then it frequently stops over there, and the operationalization that can be like a huge issue in an organization also, sometimes due to some legacy. Now, if you look at the field of AI, what strikes me a lot is that you just have like two big places where there's a lot of innovation in terms of AI. We're talking about the US, we're talking about China. And then if you look at Europe, it seems we're lagging a little bit behind in terms of AI. First of all, do you agree with that? And secondly, since you're like having your roots in Europe but now living in the US, could you point to some reasons you think this might be the case?
I think there's a lot of truth that US and China are leading the way. I would say it's a bit less true than it was maybe 10 years ago, and definitely less true than it was 20 years ago. When I came to the US 20 years ago, I would say there was nothing comparable in terms of AI activities anywhere else. China wasn't on the radar at that point, and Europe didn't have that much going on compared to US. I should generalize, but like Canada and US both had a lot going on and still have some of the most going on. I think what's changed is that the presence of DeepMind in London / Europe, if you want to call it Europe still, I think DeepMind is clearly one of the leading AI institutions in the world. Like nobody would dispute that, I imagine. And they are in London, and that is in Europe, and it's brought, I think, a lot of people back who maybe traditionally would have stayed in US or Canada and said, well, I can move back to Europe. Not anywhere in Europe, maybe just yet, but I could move to London. DeepMind is fantastic. And I think from there it started to spread a little bit, because once you're back in London, then maybe you go visit more frequently where you're actually from, and you start planting some seeds there. And so I think over the last 10 years, there's definitely a lot more activity in Europe, I would say, than before that. I think you could probably I would probably still argue US, Canada, and China have more activity. But if you have one of the leading institutions in DeepMind, that's a pretty big deal. And DeepMind associates with universities in Europe, Oxford, I think, Imperial College, UCL, and so forth. And so it grows. And Google has offices in Zurich. Google Brain, which is one of the other leading institutions, even though it's mostly in Mountain View, they have a Zurich presence. And so I think it is shaping up to be, I would say Europe is becoming very, very competitive.
Okay, that's nice to hear, and also promising for us, You were mentioning DeepMind, and what you see over there is sometimes amazing examples of robots playing like their own computer games with OpenAI. You saw like the hide and seek example, where you really see like intelligence being generated using reinforcement learning. In your opinion, because these are still kind of toy examples, right? Where do you see like even like these very nice examples being more operationalized in business?
There's kind of two things I want to highlight here. One thing is actually the answer to your question, how it'll get operationalized in business. But the first thing I want to highlight is there are definitely toy examples, right? Playing games. I mean, we don't need AIs that play games. I mean, games are for our entertainment. They're not there, for AIs to be busy playing games. But if you think about kind of the long-term picture, right? And you want to build a really intelligent system, we're a long way away from that. We need to do a lot of research to get there. And the way research is done is by having ideas, intuitions, maybe some mathematical derivations leading to, even further intuitions and so forth. And as you have those intuitions, in AI, there's essentially nothing we can prove. There's no such thing as, we have this idea and we'll just prove that this will solve all of AI. That's not really a thing. It's an intuition that you can then implement, and it might or might not work, and you'll empirically find out how well it works. And because it's such an empirical science, being able to iterate very fast, try ideas very, very fast is key to progress. And that's why a lot of the progress that we see highlighted that comes out of research labs looks a bit toyish, and actually is a bit toyish, but fundamentally, it allows us to test these ideas and allows us to iterate. And for every paper that comes out, we might have tried 10 other things that didn't work, maybe more than 10 other things that didn't work. You don't always see those, though there's more and more calls for also, maybe writing up some of the things that didn't work so other people don't try the same thing over and over that doesn't work. But that fast iteration is key. And I think games, as well as simulated robotics, are the hallmarks of what people work with and are really good test beds because they allow for testing these ideas in a way that, yes, is not as realistic as the real world, but you still get a lot of things right by doing research in those environments. Now, and I think they'll continue for a long time. We'll do research in those simulated environments. Now, as I want to transition to real world, in robotics, there's a natural transition. What I'm most excited about, of course, is because we already do a lot of research in physics simulations. Physics simulation, sure, it's not exactly matched with the real world, but at the same time, it's not crazy different from the real world. And so a lot of the things learned there, lessons learned, can be applied when we then run it in the real world. The real world will run slower. The amount of data collected, will take longer to collect the amount of data that's needed. There will be more variation, so more data will be needed to even succeed. But if we know we have the right idea that worked well in a wide range of simulated environments, then there's a high chance that if we now put the effort into real world data collection, it'll also pay off. And so that's how I see kind of transition from research to real world applications. It doesn't have to be directly the research artifact that carries over, but the approach, the fact that the approach works now allows us to invest the extra time and effort and monetary resources into doing the same thing in the real world. Now, when I think about business applications, robotics is a big one, of course. When we think about things related to games, because that's what you alluded to, which means decision making, not just pattern recognition, but really making a decision, something happens, make the next decision, at the end achieve something. Now, robotics, of course, is like that, but also dialogue. If you want a support agent, automated support agent, today they might work based on pattern matching. You say something, it says something back based on what somebody else has said back in the past. But that's limiting because that's just, parroting the same thing somebody else would have said, but the agent is not able to think through the consequences of its actions. And what you really want in the end is an agent that is like, okay, clearly this person wants, I don't know, some support ticket resolved, something's not working, they receive something that's broken, or they want to ship this back and they don't know where to ship it or whatever. You want to understand their problem, help solve it, as opposed to just repeat a pattern that was in previous conversations. So I think we'll see much more intelligent dialogue agents coming from this whole realm of what you think about as game and simulated robotics. Really, reinforcement learning is the tool behind the scenes. Another big one that's starting to pop up is essentially robotic process automation is the denominator of this. Is anything we do on a computer, and it's digital work. We might be editing a spreadsheet, and I think we've all experienced it. You edit a spreadsheet, and you're like, okay, I'm going to do 10 times more of the same thing or 100 times more of the same thing. And you're like, maybe there's a way to program this to do this automatically, but that'll take me longer than just doing it 10 more times. But those kind of things, I think an AI should be able to help with. We recently saw the OpenAI release of the Copilot for GitHub. GitHub is where software engineers keep their code and so forth. And it's something that allows to essentially autocomplete. As you're writing software, it'll say, well, given what you typed so far, we think this is the next 10 or 20 lines of code that you were going to type. And sure, maybe it's not always perfect, but it might be mostly correct. You make a few small tweaks, so maybe it is correct. So I see things transitioning into the real world, and I also see pressure for that. I think it's two things. One, the technology is becoming more mature, even though there's a long way to go in terms of research, of course, to get to anything like human level intelligence. It's good enough to build applications, but also, if you look at an OpenAI, it used to be pure research, but now they're building products. They're building a language engine. They're building a coding copilot, because ultimately, if you want to keep doing research, you also need money, right? And so you need to balance the books.
You give the example of, for example, machines starting to be able to write their own code. If you look at the example of AlphaGo, where Lee Sedol got beaten, a human getting beaten by a machine, some people also get scared, and you see like some people saying, okay, we need to regulate this more. In Europe, for example, you start seeing like the first regulations putting in place. What is your view on that? Do you think like AI at this point should already be like heavily regulated? To what extent? What should be regulated? Or do you think like, yeah, it still needs to be like open and don't put too much limitations on this because it will limit the evolution of AI?
Yeah, I think you're hitting upon exactly what the trade-off is very often, right? As you introduce regulation, you might limit progress, but it might not be limited in other countries where they don't have the regulation, and then all of a sudden, you might fall behind. I think maybe part of the solution here, and I hope the EU is going in that direction, is I'm not sure you need to regulate the research per se, but need to regulate the impact of the systems on the world, right? So, for example, might not need to directly regulate maybe, self-driving car, but you do need to regulate something about, if a self-driving car gets in an accident, then they need to be, there's a consequence, right? It should not have gotten into an accident, just like a person, should not cause accidents, just the same way, an AI shouldn't cause accidents. And of course, some thought would have to go, you can't really blame the AI directly. It kind of presumably is then that the people or the company building the AI would be, found at fault. Similarly, if a person is not supposed to look into private information, exploit private information to, gain an advantage in some way, then similarly, an AI should not, be allowed to, gain advantages in certain ways for a company by leveraging private information that you would never allow a person to take advantage of. And so I think maybe one of the nice things is that there might be a path here where essentially its consequences can be regulated without necessarily slowing down the actual progress at its core. I'm hopeful, but we'll see. It's always hard to get regulation right. So I mean, even if in principle it could be gotten right, maybe that doesn't mean it always gets nailed exactly right. So.
One thing what I also notice is I'm also working in the field of AI for quite a long time, and I'm amazed how fast this field is going in the last years. You know, if you look at the models that are being developed, they're just huge in terms of computational power. For example, OpenAI with a GPT-3 model, it's just like billions of parameters to be estimated, costing millions of euros of computational power. And then I'm wondering, like, okay, is AI only for the big tech companies who have the capital, who have access to a lot of computational power, who have access to more data typically also? Or is there still a role for startup organizations, researchers, for example, with less capital? What is your view on that?
It's complicated. I think for one, if you do have more compute, I think there is a way to build an advantage out of that. Because it allows you, as you said, train bigger models, but also very often it's not just about training bigger models. It's you don't even know exactly how to train your models. You have some rough idea, and you might say, well, maybe there's like 100 different ways we could do this. I don't know which one's going to work, and it's hard to know ahead of time. Well, if you have a lot of compute, you just run all 100 experiments in parallel, and you have the one that works, as fast as you could have run one, because you'd all do it in parallel, right? So there's multiple advantages to having more compute. I'd say especially at the frontier of kind of proving something out that's never been proven out before. There is this funny thing, though, that very often once something has been shown, somebody shows that something works, and people know that this can work. Often it's very fast for others to replicate because they have a very clear target. And we've also seen, for example, with GPT out of OpenAI, which is definitely very expensive to train, we've relatively quickly seen much cheaper versions that are fairly competitive. And so that's been really intriguing to me. And this notion that, okay, once something exists, such a clear target, let's see if we can do it as well, if we can do it cheaper, sometimes 100 times cheaper, 1,000 times cheaper, which is pretty amazing. Now, of course, the flip side to that is, well, then, OpenAI could, of course, use, a big company with a lot of computer resources could say, hey, now that we know how to do it cheaper, let's just make the network another 1,000 times bigger because we have an approach that's 1,000 times cheaper. And so in that sense, that'll probably keep happening. It'll be interesting to see what the limits are. Right now, there's definitely this sentiment that compute is a competitive advantage in terms of building the most capable neural networks. That doesn't necessarily mean an advantage in doing the most groundbreaking research, which is still different because that's about proving out new ideas as opposed to building a new specific artifact that has absorbed the most data possible. But yeah, it's been very interesting to see these large models seem to have no end in sight in terms of you make them bigger, feed them more data, and they become even better, which is pretty wild to see that happen for the last 5 years now, I would say, consistently that same trend. But it might stop at some point. It's hard to know. It might be at some point it's like, okay, making the models larger is not helping anymore. It'll be interesting to see. Or maybe it's like for a given application, there's only up to a certain size helps. Not sure what that size will be.
To be researched,
Yeah. There is something else, though, which is happening, which is, of course, that often these models are trained by a big company. And actually, there are some open source companies out there like Hugging Face that shares the models for everybody to use. And then you can grab that model that's been trained and was expensive to train and then adopt it for your application, right? And yes, the training is very expensive, but running it inside your application or adapting it a little bit for your application might not be so expensive. And so one of the most, at least to me, most surprising results in AI research in the last year that actually some of my students did in my lab, they show that you can take one of these gigantic language models that's trained on, cost a lot to train. You can actually reuse it to solve other problems by just putting one layer in front and one layer behind. It's a super deep model. You add one layer in the front, one layer in the back. Not a lot of training has to happen because it's like a tiny fraction of the network is the first layer and the last layer because so much in between. And the things in between, we didn't really have to retrain. And so you could very cheaply adopt it to different application domains, which was very interesting.
Maybe another question is linked to narrow AI and general artificial intelligence. You know, at this moment you see a lot of models being built which are quite narrow, very specifically focused on a specific task. There is also some research on general AI, but that is still not very well developed. Do you think it's useful to do research on general artificial intelligence? And what is your expectation? When will we finally achieve general AI?
Yeah, I'll answer the last question first, by not really answering it because I really don't know how long it's going to take before we get to general AI. I think, clearly we're in a 10-year span of tremendous progress, very fast progress, but also we're nowhere near it, even though we've made very fast progress for 10 years now. When I think about what's the closest we have today to a kind of somewhat general AI system, I think the language models, GPT type models that can complete sentences, complete articles, and can be used for question answering about articles or things it's read in the past. I think that's really interesting because that's not domain specific. It can be any text on the internet is absorbed into the single model that then somehow can answer questions about all these things. So I think that feels that it's gotten us a step closer than we were before. At the same time, we've had such models now for 3 years, maybe 4 years, and they made progress. They've been becoming better, but it's not really put us all the way there. That's for sure. When you think about research, I would say, or when I think in general about AI activities, I would maybe split it into 3 types of activities. One type of activity is you leverage existing AI capabilities to build new products. And personally, I think that's where massive opportunity is right now. Because of the 5-10 years of rapid progress, so many new things can be built that could never be built before. And so lots of opportunities there. That's why there's so much venture capital going into AI startups, because there's just so many new things. Just like in internet days, so many new companies could be built because now there's this internet thing. Same thing with AI now, a similar kind of thing. Now, then there are things where you look at an application and you think this should be feasible, but current AI cannot do it. And let's push it. And when you say, is this useful? There, it's very clear what you're working toward. Hopefully you picked something useful, right? Otherwise, I don't know why you'd be doing it. But so an example would be self-driving cars. Another example is what we do at Covariant, making robotic manipulation. Take that to the next level so it can help, robots can help out in many places and so forth. You see those problems and you say, I'm going to try to push the frontier, get it done. And there the usefulness is very clear. And then I'd say the third kind of AI activity is where you do completely open-ended research. And I do think that's really valuable, actually, even though it's hard to know ahead of time exactly where the value is going to be. You just say, hey, maybe one of the things I'm really excited about these days is, what if I have an agent, an AI agent, and I put it in a simulated world? And I'm not going to give it any supervision. I'm just going to let it play. And I say, well, play, what does that mean, play? Like, well, any kid knows what it means to play, right? They play. A 0-year-old, maybe at least a 1-year-old, they know to play. They might not know the word, but they're playing. They're doing their own thing. And, if you get a dog, they're playing. And so clearly, and there's these studies that show that, if you look at nature and you look at different animals that have a longer childhood, a longer protected time where they get to play, are ultimately better problem solvers or smarter. And so to me, then the interesting question is, how do I formalize play? How do I get an agent to not, try to maximize a score in a game or to, maximize quality of driving according to some metrics, but how do I somehow get an agent to understand what it means to play? And what's going to come out of that? I don't know exactly what's going to come out of that, but I think I'm pretty confident that if we can figure this out, and these agents are, in these simulated environments at first playing, then if we figure this out, at some point, this will lead to agents that are smarter, that can now pick up new instructions much more quickly than if they had never played before. And so that's the kind of example, I think, where it's like, okay, why is this useful? It's very hard to make it very precise. At the same time, I'm very confident that if we succeed at this research, let's say in the next 5 years, that within 5 years of that, there will be many useful applications coming out of it.
Do I hear it right then that you're saying over here at this moment we're focusing a lot on supervised learning, whereas what you're formulating over there seems more like unsupervised learning, or is that like a wrong interpretation?
I think that's exactly right, and that goes back to the categorization of where in AI you are working. Are you building a product based on existing AI systems? Are you building an AI system for a specific application by collecting data and tuning the neural network models? Or are you doing very open-ended research? I would say the application building and research towards applications heavily leans on supervised learning right now, where the neural network learns the pattern from input to output from a lot of data. But most of the research, or not most, but well, probably most of the research is in unsupervised learning, where there is no input-output notion. It's just data. It needs to learn from that data. Or reinforcement learning, where the agent goes collect its own experiences to learn from and interacts with the often simulated world. And that's personally where I do most of my research at Berkeley, and where I think a lot of the most kind of open-ended opportunities are that could lead us to completely new places compared to what's possible today.
I'm enjoying this conversation a lot, but you also actually have a podcast, right? Called The Robot Brains, I'm just wondering over there, what are you doing exactly for the audience, to explain to the audience? So what are you doing exactly over there, and what is the key takeaway you got from these podcasts, Pieter?
When I thought about starting that podcast, the way it came about is last summer, we're prime pandemic time. Everybody's just, at home, right? And well, with my students at Berkeley, we're all working from home, and I was just thinking about, what would be fun to do with the students to, mix things up a little bit, even though we're all at home. And my thinking was it would be really fun if I invited, some interesting people, since we're doing research at Berkeley, I'd say, okay, invite some other researchers from other labs and have a conversation with them. Not necessarily, have them present their paper like in a standard kind of research presentation, but how they come up with the ideas, what's their life like leading up to it, and just get to better understand who this person is and just enjoy that kind of background stories and everything. And the students really loved it. And so it's like, okay, students love it, and this is all private sessions. Like, well, I liked it, the students loved it. Maybe since I like it, I should do more of it. And then I started thinking about what is a broader topic that is not just specific to students doing PhD research, but that I'm really excited about, and the rest of the world might be very excited about. And for me, it's pretty clear. It's the fact that AI is becoming very real, including for the physical world. I think we're at this kind of transition point where AI is becoming viable for many physical world applications. And so it's like, okay, that's what I want to find the guests for, and have conversation with these guests, the leaders in this space, and help people, learn more about both what's happening in that space. I mean, we've had, leading leaders, founders of, companies that do drone deliveries, that do, self-driving, robotic manipulation, many domains where we're really taking AI into the physical world. And so I thought that'd be really fun to do. And we've also kind of stretched it into, venture capital. Last week, you might know, we had one of the world's leading venture capitalists on, Mike Volpe from Index Ventures, who invest in a lot of AI companies, including invested in my own company, Covariant. And so it's been really fun to kind of hit up the spectrum of where AI is really transitioning into the real world.
I'm really enjoying these podcasts, Peter. So I hope you will continue making these also post-COVID times.
Yeah, I think I will. I'm enjoying it a lot too. It's just a lot of fun to have those conversations and also to then later hear from people that they really enjoyed one of the episodes and learned something. It's very rewarding for me.
You have already like an amazing career, but what is your dream for the future?
Sometimes ask myself that question. It's not an easy question, I think, to really know what you want. I mean, all of us have to make that decision for our lives, right? I do know what I really enjoy, and I think part of what I like spending my time on is the things I enjoy doing and where I feel like I'm somewhat uniquely qualified to do them well. So if I weren't doing them, maybe it wouldn't be happening as much. And so the things I really enjoy in that regard are one, AI research. I think there is so much more that can be done in AI research. I think, yes, a lot of progress has been made in the last 5 to 10 years, but there's so much more to be done, especially when we move away from supervised learning into unsupervised learning and reinforcement learning and really start bringing that to fruition. And so that I'm super excited every day, to think about the research there. And the second thing is, I think it's hard to imagine for me anything more exciting than building out Covariant into a really big company that has the impact on the world that we envisioned from day one, which is that if you think about the world and you think about what we do every day, you can kind of split it into two parts. There's things we do in the digital world and things we do in the physical world. And things we do in the digital world actually are really scalable, right? If somebody records a movie, we can all watch that movie. Now, in the physical world, it's very different. If you make an iPhone, well, that iPhone can only be used by one person, right? You can share it, but at any given time, one person holds that one physical object. It's not easy to duplicate. And so what I'm really intrigued by in AI for robotics is this idea that if we do a really good job at advancing what's possible there, the physical is never going to be as easy as the digital, but maybe we can get a lot closer. And I think that could really create wealth for everybody across the world and really increase our standard of living. And I think historically that's what happens, right? When you create more productivity, automated productivity effectively, you create wealth. And so and hopefully, a big part will be make sure that wealth is distributed in a way that everybody benefits. Of course, it's not just concentrated on a few people, but this notion that overall we should be able to create so much more wealth and well-being by advancing AI robotics, because the physical world is still such a big challenge. I think that that's what I'm really excited about, and I'm hoping Covariant and myself can contribute a lot to that in the future.
It was also very nice to have you over here as a first guest in our Digital Transformation Club interview series, Peter. So thank you very much for this interview. It was nice talking with you about AI and robotics and how this field will evolve in the future. Thank you very much for being over here.
Well, Philip, thanks so much for inviting me. This was a lot of fun. And hopefully we can meet in person sometime in the near future.